Hi everyone. Today I am going to discuss about motion in a plane chapter. In that I am going to discuss about magnitude and direction of the resultant of two vectors. Dear students, before that those who are watching my videos first time, do subscribe and like the videos and do share the videos with your friends. As you know about the resultant of vector in a parallelogram law of vector addition, we taken a direct formula, that is for r means resultant vector, r equal to root of a square plus b square plus 2ab cos theta, and also we discussed the expression of tan alpha directly. Okay, in today's class we will discuss how those equations are obtained from the derivation. Okay, this is also a parallelogram. Okay, here OPSQ is the parallelogram. We taken the normal line. SN is the normal line. Okay, drawn to, this is a normal line. This is a normal line drawn to OP, which is extended. Means here SN is perpendicular to OP, which is extended. Okay, here, and also we are observing the two vectors, vector A and vector B. Okay, these are the two vectors which are represented by two sides of a parallelogram, OP and OQ. And theta is the angle between OP and OQ, means horizontal as well as vertical axis. Here alpha is the angle between diagonal axis and OP axis. Okay. Here R, R means it is a resultant vector. It is a resultant vector. This resultant vector is taken on a diagonal side, and this resultant vector having certain magnitude. Now we are going to calculate that magnitude of resultant vector. And also this resultant vector makes an angle, with a horizontal axis. Okay. Here our horizontal axis is OP. Okay. OP is the horizontal axis and OS is the diagonal axis. The angle is alpha. We are taking the tan of alpha. For finding the equations, we are taking the relations, that is Pythagoras formula. As you know that the square of the one side of a triangle is equivalent to addition of square of two sides. Okay. Means here there are two possible triangles are there. One is triangle OSN and another triangle, small triangle, right angle triangle, that is SPN. SPN is also triangle. We are taking the comparisons between triangle OSN to the triangle PSN. By comparing means we are taking the sine magnitude as well as cos magnitude, and we are taking those values for finding the equation, means resultant vector magnitude. Here from the right triangle OSN, means this is a bigger triangle OSN. Here you can see the diagram OSN. This is a bigger triangle. Okay. From this triangle we are taking the Pythagoras formula. Here OS square equal to ON square plus SN square. Next OS square equal to ON square. That term we are splitting. ON square means OP plus PN square. ON means, here you can see that ON is a direct form that we are splitting into two terms. ON equal to OP plus PN. Here you are observing. Okay. OP plus PN. Okay. Take it as a equation 1. Okay. From the triangle PSN. Here PSN is the right angle triangle, means another triangle which is in small size, triangle PSN. Okay, or you may take it as PNS. Okay. Okay, from this triangle again we are finding the sine and cos values from triangle PSN. Hmm. Sin theta, we know the formula. Sin theta means opposite by hypotenuse side, opposite by hypotenuse side. Here opposite means SN, from the diagram SN, this is the opposite side, and hypotenuse means PS or SP, this is the hypotenuse side. Okay. Okay, SN by PS equal to sin theta. SN equal to, interchanging the terms, PS sin theta. PS means B, from the diagram PS means B. Why? Because in a parallelogram opposite sides having the same magnitude. Okay, that's why here this is the opposite side of PS, that is OQ. Okay, having the value B. Okay, so B, and also for cos theta we are taking adjacent by hypotenuse side. Okay, this becomes B sin theta. Next one is cos theta. Now only I discussed adjacent by hypotenuse side. Adjacent side is here, this one. PN is the adjacent side. Okay, and hypotenuse means this one. Okay, interchanging the terms, Pn equal to PS cos theta. PS means again from the diagram B cos theta. Okay, now we have the values for Sn as well as Pn. Okay, using these values in a equation 1. Okay, from the equation 1, OS means diagonal side, the value is R. Okay, R square. Okay, that equal to, here A plus B whole square, A plus B whole square. Already we have the values from the diagram. Here OP means A, from the diagram OP. Here OP means vector A. That value becomes A plus B cos theta whole square plus B sin theta whole square, using the Sn and Pn values here. Okay. That becomes R square equal to, this is in the form of A plus B whole square. Expanding that formula, that becomes A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. A square as it is plus B square is common for two terms, taking B square common, then into bracket cos square theta plus sin square theta. Okay, this value becomes 1 plus 2AB cos theta here. Then according to trigonometric identities, sin square theta plus cos square theta equal to 1. Okay, using that value here, A square plus B square, this value term becomes 1. Okay, next plus 2AB cos theta, it is in the square form. Next we want a individual term, resultant vector magnitude, that's why taking the root on the right side. R equal to root of A square plus B square plus 2AB cos theta. This is the expression for magnitude of resultant of two vectors. Okay, and alpha, alpha is the angle made by the direction of R, means diagonal axis, with the direction of A, means horizontal axis. The angle is, we taken that alpha, tan of alpha, from triangle OSN. Okay, tan alpha equal to Sn by On, tan alpha equal to Sn by On. Okay. Opposite by adjacent side. The from the diagram, Sn as it is, On means we are splitting that term OP plus Pn. From the previous terms, we have the values. Sn means B sin theta. On means already splitted into two terms, OP plus Pn. OP means A and Pn means B cos theta. A plus B cos theta. Okay. This is the tan of angle. Means it is direction made by the resultant vector. Okay. Take it as equation 3. Next. Here equation 2 gives the magnitude of a resultant vector. Here this is the magnitude, equation 2. Okay. This represents the magnitude of a resultant vector, and this is the equation 3 which gives the direction. Okay. This is an important derivation for annual exam purpose. Okay, next one. Next concept is resolution of vectors. First, we will discuss about what is meant by resolution. Okay. Resolution means resolving a certain quantity into axial components. Here, the word axial components means in terms of x component as well as y component. For example, we have the numerical value 4. Okay, 4 is there. That 4 can be splitted into 2 plus 2. Again, after adding these two values, we can get 4. Okay, means here we are resolving this 4 magnitude into x component, y component. Means along x component 2 value is there, along y component 2 is there. After adding, again we will get 4. Okay. In the same way, here 4 is the vector which represents certain quantity. It may be a position or displacement or velocity or anything. Okay. Here I am taking the position. Okay. Like that, the same way we are resolving a vector, given vector. Okay. Here vector is A is there. That vector can be splitted into axial components, x component as well as y component. Here this is a diagram. Okay. Here O is the origin position, x component is there and y component is there. Vector A is there, OS is the line segment, OS equal to vector A. Here this vector has resolved into two components, x component as well as y component. Along x component we have the term Ax I cap, where Ax is the magnitude of A along x axis and I cap is the position vector along x axis. Magnitude as well as position vector, that gives the whole magnitude of x axis, that is Ax. Here you are observing that. In the same way, Ay j cap is the magnitude along y axis, where Ay is the magnitude and j cap is the position vector. Here you can see that vector A resolved into Ax plus Ay. Again, with respect to position vector, that becomes Ax I cap plus Ay j cap. Like that, we are splitting the given vector into axial components. Here, from the diagram, here also we are finding the sin and cos component. Okay, again adding those components, we will get the same value. From the triangle OPS, here this is a possible triangle from the diagram. OPS, OPS is a triangle. From this triangle, again we are taking the sin and cos magnitude. Okay. Here from the triangle OPS, cos theta, OP by OS, OP by OS, adjacent by hypotenuse side. Here adjacent, OP is the adjacent, hypotenuse means OS. And for sin theta, opposite by hypotenuse side. Okay. That becomes PS by OS. Here, first cos theta, OP by OS. OP equal to OS cos theta. OP means from the diagram AX I cap means nothing but as a whole magnitude AX. Okay. X component value AX. Okay. AX equal to OS means from the diagram OS means from the diagram A, vector A is there, A cos theta. The same way sin theta PS by OS, opposite by hypotenuse side. PS equal to OS sin theta. PS means AY equal to OS means A. AY equal to A sin theta. Here we have two equations 1 and 2. Now next we are squaring and adding the equation 1 and 2 on both sides, left hand side as well as right hand side. This is equation 1, this is equation 2. Okay. That becomes ax square plus ay square equal to a square cos square theta plus a square sin square theta. Okay. Ax square plus ay square equal to a square cos square theta plus a square sin square theta. Here also taking the common of cos square theta plus sin square theta. That becomes a square. Then the value of cos square theta plus sin square theta is 1. Then remaining is a square. Here we want value of vector a. Okay. Here taking the square root, okay, a equal to root of ax square plus ay square. This is the magnitude of the vector a, means this is a resolving quantity. After resolving we will get a vector a as a root of ax square plus ay square. Next also you can find the tan of angle. Tan theta equal to opposite by adjacent from the diagram. Okay. Opposite means PS or SP. Here no value. This is looking like a this is looking like a rectangle. Okay. This value and this value is same. OQ and PS is same. And OP QS is same. Tan theta equal to AY by AX. Okay. Opposite by adjacent side. Then theta equal to shifting this tan theta into this side, that becomes inverse tan inverse of ay by ax. Okay. This is the concept of resolution of vector. In remaining class we will discuss about remaining concepts. Thank you.